Today, we're going to tear apart a document that for a lot of people feels more intense than some top-secret government file. What is it? It's a 12th grade chemistry final exam. We're going to deconstruct this thing piece by piece to really see what it's asking of these students.
Right on the very first page, the stakes are spelled out clear as day. 70 marks, 3 hours, that's it. Every single minute, every single point is a battle. You know, this isn't just a test, it's a performance where your future is on the line.
So, here's how we're going to break it all down. First, we'll talk about that 3-hour pressure cooker. Then, we'll decode the rules of the game. We'll go on a little sprint through the chemistry topics, see how they connect theory to practice, and then build up to the ultimate challenge. Finally, we'll step back and ask, what does this whole thing really tell us?
Let's really set the scene here. For the student walking into that room, this piece of paper is everything. It's the culmination of years of hard work. It is literally the gateway to the university they want, to the career they're dreaming of. And it all comes down to this number, 70. That's it. That's the score that represents an entire year of chemistry. Every single point is a tiny piece of that future, and you better believe the fight for each one is absolutely fierce. Okay, now, before a single chemical formula gets written down, students have to get through the general instructions. And trust me, this isn't just the boring fine print. This is the playbook. It's the strategy guide for the next 3 hours. Honestly, understanding the rules is kind of the first test.
And this shows you just how the challenge ramps up. You can see it's broken into 5 parts. It starts you off with these quick half-mark multiple-choice questions, but then it just keeps building all the way up to these monster 5-mark long-answer problems. It's designed to test you on every level, from just remembering a fact to deeply analyzing a problem.
So what's it actually like inside that exam hall? Well, it's a totally controlled environment. You've got your trusty scientific calculator, but it can't be programmable, and log tables. And then there's the stuff that's absolutely banned. No phones, no pagers. It's a clear message, right? This is about what's in your head, not what's in your pocket. All right, so the clock starts. Now what? Well, you hit the ground running. It is an immediate sprint, because these opening questions are designed to see just how wide your knowledge base is. Let's just look at a few back-to-back to feel the pace.
So first up, we get a question straight out of biochemistry. You've got to know the literal building blocks of life. By the way, the answer is uracil. It's a simple fact, but you have to know it instantly. There's no time to sit and think about it.
And then, bam! Right after that, the exam just completely pivots. We jump from the building blocks of life to solid-state physics. This one's about the magnetic properties of iron, cobalt, and nickel. Are they ferromagnetic? You can't even pause. You have to shift gears in your brain in a fraction of a second.
And to round out this little sprint, we land in organic chemistry, talking about reaction mechanisms. So just think about that. In the span of probably less than a minute, a student has to pull information from biochemistry, then physics, then organic chemistry. The mental agility you need for that is just incredible. But, you know, the test doesn't just stay on simple facts for long. It gets harder fast. The whole point is to see if you can take these ideas, these theories, and actually apply them to solve real problems. It's all about closing that gap between knowing something and doing something with it. Here's a perfect example. Early on, you get a simple 1-mark question. What is an adsorption isotherm? It's a core concept. You either know the definition or you don't. This is the foundation.
But then, just a little later, you have to use that foundation to build something. This 2-mark question asks you to do a calculation. See, it's not enough to just define what a mole fraction is. You have to take that idea, plug it into a formula, work with the numbers, and get a specific answer. That is the leap from theory to practice.
And that brings us to the main event, the absolute climax of the exam, the long answer questions. These are the big ones, worth 5 marks each. This is where you have to bring everything together, your deepest understanding, your clearest explanations. This is where the top students really separate themselves from the pack. I mean, just look at how much they've packed into this one question. It's really asking for 3 different skills at once. First, you have to state a fundamental law from physics. Second, you have to show you understand a pretty complex chemical reaction. And third, you have to do a perfect, precise calculation. To get all 5 of those marks, you can't mess up a single part. So, now that we've taken this thing apart, what's the big takeaway? What does it all tell us? Well, if you zoom out and look at the whole paper, it's basically a blueprint. It reveals exactly what this education system thinks a great young chemist should be.
Whoa, okay. This chart tells the real story. Just look at this. The multiple choice questions, the ones that are just about basic recall, they're worth a tiny 6% of the total grade. Meanwhile, you add up the short and long answer questions, the ones that need written explanations and solving problems step by step, and they make up a massive 83% of the total. The message couldn't be clearer. Just memorizing facts is not going to cut it.
So in the end, the student this exam is looking for isn't just a walking textbook. They're a problem solver. They're someone who can pull from a huge base of knowledge, use it to do complicated math, stay cool under crazy time pressure, and basically pull a bunch of different skills together to crack one tough problem. This isn't just a test, it's designed to find people who think like actual scientists. And that kind of leaves us with one final big question. This exam, as we've seen, is this incredibly intense tool, and it's built to find a very specific type of scientific mind. It's the blueprint of a chemist, for sure. But it makes you wonder, what does this very specific way of measuring knowledge tell us about what we think is important in education? And maybe more importantly, what other skills are we not even testing for at all?